Law of Motion Project by me, of course. What is the first law of motion? The first law of motion is an object at rest remains at rest, and an object in motion remains in motion, which is called inertia. As I go to my second video of the first law of motion, just wait until it loads. So you can see currently that the bar is in motion. It's currently at rest. The bar is currently at rest. So as I let it play, you can see me go ahead and try to apply a force, which is basically me kicking the ball. Stop right there. Boom. That is called an unbalanced force. So the bar remains at rest at the very beginning, and it's going to stay at rest. Once I apply the force, the ball is going to be in motion, and it will stay in motion. So you can see me kick the ball, which will make the ball be in motion, and it will stay in motion until an unbalanced force hits it or friction stops it. When I apply the force to the ball, it's an unbalanced force. This also relates to the second law of motion because the force that I apply is because it's being controlled by the mass of the ball. Since it's not heavy, it will accelerate at a faster speed. This as well shows the conservation of momentum, because the amount of force that I put on an object would transfer it back. Because for example, if I was to kick a ball / apply a force to the ball at a wall, the ball will go the same distance as the wall would, but since the wall has a greater mass, the wall won't move. But if there were the same amount of mass in the same object, they would both go the same distance. But since the wall won't move, but the ball will receive the same amount of force that I originally applied. But it won't go as far as the amount of force that I put on it because of friction, which will stop the ball from reaching its max point. Okay, let me go to the second video. Okay, for the second law of motion, the acceleration of an object depends on the mass of an object and the amount of force applied. So, for the first video, if I let it load, you can currently see me put a ball, or throw a 16-ounce ball. You can see me put a 16-ounce ball in the bucket, and now as I take it to push it, which is in the second video, now as you can see me push it with a good amount of acceleration, it won't be as hard to push it, and it will accelerate faster. Now as I go to the third video, you can see me put a 20-pound dumbbell on the cart. So there, as I push it with the same amount of force as I did to the first object, which is a 16-ounce ball that I put in the bucket, you can see me that I put the same amount of force applied as I did the first object, and you can see me that I struggled more pushing this one than the other one, and this one has a slower amount of acceleration than the first object, because the mass of an object determines the acceleration of it. So one object has a faster acceleration than the other because the mass determines the acceleration of speed. This is not the only example of the second law of motion. For example, the second law of motion can occur when I have two objects and I apply the same amount of force, but one object is heavier than the other. In the acceleration, you can see that one has greater acceleration than the other. It weighs less, so the acceleration of the object is determined by the mass. Therefore, if you want the same amount of of acceleration on two different objects, you with a different mass, with a greater mass, you have to apply a greater force to the heavier object. Last but not least, the third law of motion. Whenever one object exerts a force on another object, the second object exerts an equal and opposite on the first, which is called action and reaction. So, which is basically, now for the video, I'm going to click on it. So, as you can see me, I'm about to jump off the bucket. Right there, as I zoom in, oops. So, for example, you can see me prepare to jump off the bucket in slow motion. As you can see that my action which is jumping off causes a reaction of the bucket getting pushed away. Also, this can occur in many situations. But for right now, you can see that as soon as I'm about to jump, I apply the force, I jump off, which is my action, and then the reaction of the bucket is getting pushed away from where I jumped. This can occur in many situations, like a gun, because when you shoot the gun,